Did we do a little bit of that in class yesterday? No. Okay. I did the other two classes just because I had time, but. Increasing, decreasing intervals. So find the open intervals along which the function is increasing and the intervals along which the function is decreasing. So this is old news. If a function is increasing, what's going to happen with the derivative? Positive. So we just need to simply find the derivative. This first one would be 3x squared minus 3 halves x. Now, the critical points, the critical points that we've been finding where the derivative equals 0 or where the derivative is undefined, those are ones where on either side of it, the increasing or decreasing might change at that moment. So we still want to set it equal to 0 and solve to figure out kind of where the points of transition are going to happen, where it might be increasing on one side and decreasing on the other. So if you add your 3 halves over, divide by 3, square root both sides, x is going to equal plus or minus the square root of a half. Yes, and then you could do plus or minus root 2 over 2, but it doesn't really matter because those are our critical points. Positive root 1/2, negative root 1/2, which means at those moments the slope is 0, so it's neither increasing nor decreasing. But on the left of it, in between those two numbers, and on the right of it, you're going to evaluate any number that's just going to be straight up easy for you to evaluate and see if the derivative is positive or negative. So if I took something like negative 2, are we convinced that that's definitely smaller? Okay, so negative 2, and evaluate the slope in this interval by plugging in a negative 2. What kind of number are you going to get if you do f prime of negative 2? Positive, right? So the graph is increasing from negative infinity up to negative root 1/2. Obviously 0 would be an obvious easy one in between here. The derivative at 0 is negative, so it's decreasing in that interval. And then if you plug in positive 2, you're going to get positive again. So a couple things. Number one, we can answer the question. The intervals, it's increasing from negative infinity to negative root 1/2. And again, it's increasing from root 1/2 to infinity. It's decreasing from negative root 1/2 to positive root 1/2. Okay, so that answers the question. Further, we can actually conclude something about our critical points. Is this critical point a relative max or a relative min or neither? Which one? Relative max, relative min, or neither? If it's increasing going into it and decreasing coming out, it's a relative maximum. And then this one, if it's decreasing going into it and increasing coming out, that's a minimum. Do we follow? Okay. Any questions on that? So that it didn't ask us for that, but this test, this first derivative test, and kind of doing you did these little charts last year for different things, for maybe polynomial graphing, I think probably, but this concept is used throughout math to kind of explore values in intervals. On the second one here, take the derivative. Derivative of cosine is negative sine of x over 2. There's a chain rule here, so times a 1/2. So it's just negative 1/2 sine of x over 2. We want to set it equal to 0. Or undefined, but it's never going to be undefined. So divide by your negative 1/2, you're going to get the sine of x over 2 equals 0. So we're only on the interval from 0 to 2 pi. There's two different ways we did this back in the trig chapter when we were solving this. Because we have a change in period here, okay? So our x values can only be between 0 and 2 pi. But because this is x over 2, it's going to change things. Does anyone remember how we handled this? If x has to be between 0 and 2 pi, right, then x over 2 has to be between 0 and pi. So we essentially need to know what numbers between 0 and pi could be here. So what numbers between 0 and pi would have a sign of 0? We're not including the endpoints, correct? Then nothing, right? So whatever this graph is doing, whether it's increasing or decreasing on that interval, it's doing the entire time. Do you follow? Okay. So all we need to do is just plug something in to the derivative and see what it's doing. So if you want to plug in just pi to the derivative, sine of pi over 2 is positive or negative? Positive, so it's increasing the entire time. F prime of, if you want to just show that. So it's increasing along the entire interval. So let's look at that one to confirm, because it kind of feels a little fuzzy. Window from 0 to 2 pi. That should be fine. What happened? It should be decreasing the whole time? Are you with me? Cosine of x over 2. When I plug in pi to the derivative, oh, I didn't plug it into the derivative. I plugged it into the simplified version. That's the problem. I should have been plugging pi into there, right? That's my derivative. Good thing we checked up on this. We got to learn something out of it. So I should be plugging pi into the derivative to see what it's doing the whole time. And if you plug pi into here, you get that it's got a negative slope the entire time, so it's decreasing. Because I know that there are no critical points, right? So whatever it's doing the entire time. I don't have little intervals to check on either side of. So because there are no critical points on that interval, whatever it's doing, whether it's increasing or decreasing, it's doing the entire time. So I just need to plug in any number on my interval to the derivative and see if it's positive or negative. Problem is I plugged it into this simplified version. I should have been plugging it into the derivative, not once it already equals 0. So if you plug that pi in, the sine of pi over 2 is 1. 1 times negative a half is negative the entire time. So it is decreasing the entire time, not increasing. And obviously, I knew something was wrong because when you check it, it didn't look right. Okie doke. Any questions?
Yeah, about the one on the first one.
Yep.
I know that it's maximum because the derivative graph is.
It's increasing into. This is an evaluation of your derivative.
Yeah, so it's positive.
So if the derivative is positive, that means the actual function is increasing leading up to this point, up to the critical point. And then if the derivative becomes negative, that means the slope is negative. That means it's decreasing coming out of it.
About the derivative graph, I'm like, if it's positive above the x-axis.
Yeah, no. Okay.
Yeah.
All right, next one. We need to find our derivative. Quotient rule. Go ahead and do that. Okay, so any place where our derivative is 0 or undefined is a critical point is going to put us on our number line. So this is going to equal 0 if the numerator is 0, which will be where? 0, -2 are critical points, good, where the slope is 0. So these two are potential relative maxes, relative mins. And in the denominator, where it's undefined, that also is a critical point. So that would be at -1. Now, if you look back to the original, that's a critical location because it's an asymptote. Yes? So it's not going to be a relative max or a min there, but when you're surrounding an asymptote, the increasing to decreasing happens, or can happen, depending on the behavior on either side. So we're just going to go ahead, take our derivative, which this is the simplest form of the derivative, plug in a -3. So up top you would have a negative times the negative, which is a positive over always positive on the denominator. So that's increasing from -infinity to -2. Then if you plug in like -1.5, your numerator will be a negative times a, if I'm plugging in -1.5, right? So a negative times a positive is a negative over the denominator, again, will always be positive, so it's decreasing there. If you plug in -0.5, you're going to get a negative times a positive, which is a negative over a always positive, so that's still negative. And if you plug in a positive, you're going to get positive, positive, positive over a positive is a positive. So, as far as our intervals are concerned, what this question is asking is that we're increasing from -infinity to -2, and we're increasing again from 0 to infinity. We are decreasing from -2 to -1, and we are decreasing from -1 to 0 as well. We are not decreasing at -1 itself, just in the interval between. So you have to split that up. So I'm just going to write the decreasing one. We're decreasing from -2 to -1, and again from -1 to 0. But that is written that way so as to not include -1. Our slope is technically undefined at -1. It's undefined because there's an asymptote there in this particular case. Okay? So as far as relative maxes and relative mins, is that relative max, relative min, or neither? What do you think, Winter? Zach, would you agree? Pay attention, please. It is a maximum. It is increasing going in, decreasing coming out. So that is a relative max. This one is going to be neither regardless because it's an asymptote. This one's decreasing coming in, increasing coming out. So here is the graph of that. And you can see at -2, there's your relative maximum. It's increasing going in, decreasing coming out. You can see your asymptote. So obviously on the other side of the asymptote, it's still decreasing. That's why we got a negative on both sides here. And then negative and then positive, and that's our relative minimum at 0. Okie doke. All right. Last one here. A little bit of a different graph. Find your derivative. So when is this? Where are our critical points? Give me a critical point. Ellie. One half. How are you getting that? Okay, if I set it equal to 0, I would add my 4 over x squared over, so 1 will equal 4 over x squared. If you multiply both sides by x squared, you get x squared equals 4. Not just 2, plus or minus 2, right? Okay? So, positive 2, negative 2. If you look at like 1 minus, it would have to be 1 that would equal 0, right? So that fraction has to equal 1, which means that denominator has to be 4, which means x could be plus or minus 2. So it makes that 4 over 4. So I kind of asked a little prematurely because some of you might have noticed that. How about other critical points, Michelle? There's another one. Fill in the blank. Critical points are when the derivative equals or. Okay, now do you know the other critical point? Zero. This is our derivative. It will be undefined at 0. So now to find our intervals, we just have to plug in numbers. Like at negative 3, we got to find out what this graph is doing. So if I were to plug in a negative 3, I would get 1 minus 4 ninths. Is that positive or negative? It's positive. 1 minus 4 ninths is 5 ninths. If I were to plug in a negative 1, I would get 1 minus 4 over 1. 1 minus 4 is negative. And pretty negative, so it's decreasing fairly quickly there. If I plug in 1, same thing, negative. Now, 0 is an asymptote anyway, so that's not uncommon to see that. And if I plug in 3, I would get 4 ninths. 1 minus 4 ninths, again, is a positive. So if you want to, just so you remember, you can put like an asymptote through that number just so you can kind of remember that that's never going to be a relative max or min, even if the behavior changes on either side. I know we haven't seen that yet, but sometimes you can have it decreasing into an asymptote and increasing coming out, and that still would not be a relative max or a min. So our interval from negative infinity to negative 2 and from 2 to infinity, we are increasing. We are decreasing from negative 2 to 0, and again from 0 to 2. Negative 2 is a relative what, Jack? Maximum. 0 is nothing for the asymptote reason and because there was no change anyway. Negative into positive means 2 is a relative what, Haley? Minimum, decreasing to increasing. So if we just take a peek at this graph just to convince ourselves, whoops. That was very difficult for me to type in. Almost looks like a similar graph. So we are increasing up until negative 2. We then start decreasing after negative 2 up until 0 because there's an asymptote there. We're still decreasing on the other side up until 2, and then we start increasing. So we have a relative max, relative min. Adam.
What makes it like absolute max and absolute min?
You would have to actually look at the y coordinates of your critical points to see that. So if you have, you'd have to look at, and here,
Find the y of it.
correct. You have to find the y coordinate. However, when we're not limited to an interval, you like a lot of times based on n behavior, there is no absolute maximum. There is no absolute minimum because these will go down and up forever. So usually we'll be looking at a closed interval, so you check your endpoints as well as the critical points in the midst of the function. Well, they didn't tell us only look at this function from, -5 to 5, so to speak. So if they did, you would find the point at -5, you'd find the point at 5, and even that would be tricky because obviously with the asymptote in between, it's going to go to, there is still not going to be a relative max or min. So you have to cut the interval or think about end behavior sort of things. That's a little bit more complex. You're not going to see that tonight, I don't believe. Good question, though. Anything else? Okay. Just generally speaking, if the derivative is less than 0, meaning the derivative is negative, then f is decreasing. So if the derivative is negative, then the original function is decreasing, and if the derivative is positive, then f is increasing. So you're just finding your critical numbers and testing points within those intervals. This is what I was just doing on the front anyway. I was finding the relative extrema, even though the front directions didn't ask me for it. So why don't you do these 4 on your own? Okay, so on the first one, we'll talk about this because it's a little bit trickier with the trig. I've got the endpoints of my interval, 0 and 2 pi. I took the derivative, set it equal to 0. I needed to know where the cosine is going to equal positive 1/2. I know that cosine is positive only in the first and fourth quadrants, and the reference angle is pi over 3. So for the first quadrant, that's exactly pi over 3, and for the fourth quadrant, that's 5 pi over 3. Now, testing things in your interval. So between 0 and pi over 3, what's a decent number to check between 0 and pi over 3? Pi over 6. So if you check pi over 6, the cosine of pi over 6 is radical 3 over 2. 1/2 minus radical 3 over 2. Positive or negative? Negative. Remember that cosine starts at 1 and gets smaller towards 0. So once you get up here, the cosine will be a pretty small number, and 1/2 minus it will leave you with a positive number. Okay, anything in between pi over 3 and 5 pi over 3. And if you take something easy like pi, okay, the cosine of pi is -1, so 1/2 minus -1 will leave you with a positive. And then in this last little sliver, as the cosine is kind of getting back to being +1 again, so if you check something like, well, you check pi over 6 on this side, you could check 11 pi over 6 on that side, and it would be the same value. because the cosine of pi over 6, cosine of 11 pi over 6 are the same number. So that's also going to be negative. So your relative extrema are pi over 3 is a what? Minimum. Now, we will find the y-coordinate, because when they ask for the relative extrema, that's the point. So pi over 3, when you plug it in, a half times pi over 3 is pi over 6. And minus the sine of pi over 3 is minus root 3 over 2. So it's not a pretty y-coordinate, but it'll do. This is a relative minimum. So we're decreasing going into it, increasing coming out. Then we start decreasing again at 5 pi over 3. So 5 pi over 3, comma something is a relative maximum. And again, half of 5 pi over 3 for coming up with a y-coordinate is 5 pi over 6 minus the sine of 5 pi over 3. Be careful here is what? The sine of 5 pi over 3. What's negative, right? Negative, because we're in the fourth quadrant. So because the cosine is the same regardless, but we're not evaluating the derivative. We're evaluating the value. So it's minus a negative, which will turn into plus root 3 over 2.
It says just find the relative extrema. Don't you just do what we did like 2 days ago and do that and
Endpoints would never be relative. And if it said find the extrema, then you could go and do that. But relative is just, and the first derivative test really tells you just relative because you're looking at the change of behavior on either side. You don't have either side of your endpoints. If they did want the maximum and minimums as well, you'd actually have to crunch numbers and figure out what these y-coordinates are, as well as figuring out what the actual endpoints are. Of course, this is a bracket anyway. Or a parenthesis anyway, but assuming like if it was a bracket, you'd do 0 comma and 2 pi comma and just compare all your y-coordinates for absolutes. Okay. Number 2, find your derivative. Go ahead and do that. Don't forget your chain rule. Simplify. Where are our critical points? Kyle.
0.
Yep, where else?
2.
Yep.
-2.
Yep. Now, the graph is defined for all of those. Okay, so the undefineds here are not coming because of asymptotes. Are you with me there? If you plug in 2 or -2 to the original, you're not getting asymptotes there. But the derivative is undefined there, which means it might come to a sharp corner point. We can look at it in a minute. But test -3. So if I plug -3 in, I'm going to have a negative on my numerator over, that's going to be 9 minus 4, cubed root of 5 is a positive times negative over positive is a negative. If I plug in -1, I'm going to have a negative up top over 1 minus 4 is a negative number. The cubed root of a negative number stays a negative number. Times 3 stays a negative number. So negative over a negative is a positive. If I plug in 1, I get a positive over a negative, which is a negative. And if I plug in a 3, I get a positive over a positive, which is a positive. So I have decreasing to increasing. So negative 2, I'm going to just bypass finding my y coordinates because that's just busy work at this point. A relative minimum, I've got 2 of them. At x equals negative 2, decreasing to increasing. And then at positive 2, decreasing to increasing. And then a relative maximum, if I'm increasing to decreasing at 0. And that's it. So let's look at this one and kind of wrap our heads around why the derivative is undefined at plus or minus 2. Any guesses? Why is the derivative undefined there? Here's what your graph looks.
It's shifted over for it can exist.
The original graph doesn't exist over there.
At 2?
Yeah.
Why not? 0 to the 2/3 power? 0 to the 2/3 power is 0. So once you see it, it's because it comes to a sharp corner point. It wasn't for the sake of an asymptote like we saw in the other problems, which is why it can be a relative min or a relative max. Good? Okay, next. Go ahead. Go ahead. If you're falling asleep, do them on your own. Stay busy. So your critical points here will be at what, Nathan? Good. 0 is undefined in the denominator, and that is, go back to your original, that is because of an asymptote. And then positive 1 and negative 1. So if you test negative 2, you're going to get a positive over a negative. If you test negative 1/2, let's see, 1/2 to the 4th power is going to be like 1/16 minus 1. That'll be a negative number over a negative number, which is positive. Positive 1/2 is going to be a negative number over a positive number. That's negative. And if you plug in 2, you're going to get a positive over a positive, which is a positive. So we have decreasing, increasing, decreasing, increasing. So we've got relative min at negative 1. This, like I said, this is an asymptote. So do not call that a relative maximum. Do you follow how you have to keep that in the back of your mind? 0 was an asymptote, so it cannot be a relative maximum. This is a relative minimum, this is a relative minimum. So if you look at this graph, x to the 4th plus 1, parentheses, divided by x squared, here's what we're looking at. Okay, so the reason you saw a shift in slope on either side of the asymptote is because it was a double root kind of asymptote, x squared. So your asymptote at 0 had a double root, so it was increasing on one side, decreasing on the other, but that cannot be confused as a relative max. Okie doke? I don't think we have time for the last one.
If you did it, like, how would you know if you don't have an interval?
Did you already jump into it?
Yeah, but I don't know, like, where to go.
Here, give me it.
There's no interval.
This will get us to our answer quicker. So I see what you're saying.
Just input number.
So he found his derivative, cleaned up his derivative. It's never undefined, but you said it equaled to 0.
That one's stuck. Like,
Oh, I don't know if I forgot it, or you might have to say at all x values. So x, for example, would be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So you might say odd pi's over 2.
don't you know the 0?
No, cosine of pi over 2 equals 0. So you would t that and just say like something like that, like k pi over 2, where k is an odd integer, something like that. I might have just forgotten to put the interval in there as well. Just kidding, Stephen.